Hello, can you hear me? Hey, there you go. It's working now. Man, I have literally changed nothing at all, and all of a sudden the mic just wasn't working. It just decided to use a completely different source. Go figure! Software, man. It's terrible. So, how's it going? Good evening, everybody. We've already got one sub. That was Outwolf. Thanks, dude. As always, you are a legend for supporting. And you're a legend regardless anyway, but that's fantastic. So, good evening to Archbishop. Good, I'm going to guess morning to Nomad. Greetings, Zorcat. Who else we got? Rasta, that's got to be a morning to you as well. Thanks for jumping on. And to whatever other regulars happen to be sitting behind the scenes, thanks as always for joining in. I hope you're all good. Oh no, it's Russ. I know, haven't been able to shake that guy. Comes on here with all his fame and stuff. Everyone gets woozy at his presence. No, it's good. Good to have you all on. I appreciate it. So I'm not going to muck around. We're just going to pretty much get straight into it. Tea. Hacking without tea is very uncivilized. I am again back on the Dong Ding Oolong tonight. I haven't had one, I don't think, since the last time I had one on stream, which is actually quite some time. I've been getting into the Gyoko again. Also, I managed to, at the last minute, dig up this, which I opened on the last stream. So hopefully you all have a respective beverage and snack of choice to get us through the next, what will hopefully be productive 2 hours, where we decide to finalize packet pivoting. That's the plan. If we can get past that, then we're going to get stuck into building the reverse name pipe transport for .NET. Love a good dong ding in the evening, don't we all? The stream in memory of Lustu-ID. Oh man. Like, I don't genuinely get upset about things like that very often, but that news of Lustu-ID dying absolutely wrecked me. I shit you not. That was just... that was horrible. I'm still a little emotional when I think about it. 16 years old, decent human being, whole life ahead of her. I can't believe that she's gone. Like, yeah. Rest in peace, huh? She was incredible. Anyway, cheers to you, Luce. Man, such horrible news. Hey, Binchuk, good to see you, dude. Barney, with the extra sub again. Thank you, mate. Appreciate your support, as always. One of the longest supporters on stream up there with that wolf. I appreciate it. All right. Let's fire up the virtual machine and get stuck into some work. Okay. I had to open this up and change the IP address again because for some reason things were broken. Which means I'm going to have to do it here as well. 138. There we go. Hey OJ, it's Will. It is Nelson from The Simpsons. That's right. You can see him. You can see him just sitting there, like just over my shoulder, just letting me know how many mistakes I've made. All right, let's just make sure that this works like it did last time. Go, go, go. Build, run, do the things. Is it running? Go. Okay. Just make sure that it's all doing what we want. Okay, so it's running. Kill that off. Okay, so we're all good. Vim in VS. Yeah, man. Always. I can't do without Vim. We've been here before. So, yeah. Okay, so where we got to last time I believe we were at the point where we were actually starting to read data that came in off the wire. And so when that connection first came in, we need to inform Metasploit that a new session has come in, right? So let's go back to, again, the Halos repo, and we're going to go and have a look again at the messages that go back and forth. When is the Vim Adventure stream? Not for a little while, Barney. I'm super keen to continue pushing through what we're doing now. Otherwise, it's just going to last forever, you know. Metserve. Okay, so pivot packet dispatch. I think there was something in here that was interesting. Nope, wasn't that one, but we will need that, so I'll leave that there. Okay, so what is it? I can't even remember where we were, but it had something to do with pivot create. This is how good I am at this stuff. Pivot manager, core pivot add. There you go. Core pivot add. So that will give us request. Of course, it's always prefixed with request, isn't it? Okay, so this is where we began. Now, where were we? Must have something to do with .NET. Yes, let's start from the very beginning. Okay, core pivot add named pipe. Sorry about this. Where are we? Here, server pivot name pipe. Of course. So once we go through the pain of doing all of the things, we end up called pivot tree add, create pipe instance. Here we go. So that's right. So once we've got the actual pivot in memory, we then expect packets to come in on that pivot. So I think this is where we were looking before, right? Connect. So here we go. We need to tell Metasploit about it. I think this is where we got to last, right? So where is the outbound message that we need to send? Here's where we do the staging. Here we go. That's what we need to do. So we're creating a request called core get session. Ah, that's right. This is where we got to last. So we actually talk to the remote endpoint and say, now where is that going? We create a core get session GUID packet. Packet add request ID. Yep. Copying the request ID from the packet to the context. Why are we doing that? I don't know. Prepare the packet buffer for sending. So that's just doing the XORing, and then we send that down the named pipe. That's interesting. Oh, Barney, what are you doing? Barney's doing the gift subbing thing. Thank you, mate. That's very kind of you. Ooh. You are a legend, my friend. Yeah, so this is where I got stuck in my head and decided to just stop last time because I knew that this was going to be a bit of a pain in the butt. Binchuk saved me a lot of money. Really? I believe you. He's a good bloke, that Binchuk. Okay, so read pipe to packet means pull the data off the packet. So what we're saying here is bytes processed, connection received. So what I'm trying to do is get the timeline of events right, because the packet pivot code appears to be asking what the session GUID is for the thing that came in, which actually it can support. That's right, because we've already got a Meterpreter staged ready to go. So clearly what we're doing is asking for the session GUID in case it's already got one for reconnects. wondering if this is what we should be doing anymore in the real world, because once we've got something staged, the first thing that we're going to do is negotiate TLV encryption. So I don't know whether I'm going to do this stuff here or not. But what I do need to do is make sure that MSF knows about the new connection that's come in. And so there's definitely something here that needs to support that. Read pipe to packet set context while it's processed. And then that will continue to do the reading. This has to be done after the signal is reset, otherwise strange things happen. Oh, that's good to know. Kicking off another read op. Yep, okay. Right, that makes sense. So I assume then that we end up with another function call going here. Toggle. Create pipe security attributes. Name pipe write raw. Here we go. What are we doing? We're writing to the named pipe and doing that in a loop. Tell you what, this was a real pain in the butt to implement originally. Here we go. Right, so if we're reading... Right, here we go. Read pipe to packet. So I think what we need to do at this point is there's a message that goes across the wire. All packets ready for transmission on the other side, pivot through the existing side. This is the thing that is literally taking data off the wire, generating a packet and passing it on. This is saying... This is pretty confusing, by the way. But feel free to ask questions along the way, because this is confusing to me and I wrote it. Okay, so the request ID is found and matches expected value. We have a response to our session GUID. Okay, so we query for the session GUID intermediate, and if it's null, so the session GUID is not null, and it's session GUID return looks like the session is a reconnect. Okay. Do some packet pivot related stuff. Otherwise, we need to generate a new GUID. Yep. Swizzle the values around so endiness is an issue before casting to a block of bytes. I remember doing that too. Say that we have a established session, create a pivot context, and add that to the pivot tree. Do some debug prints. Right, this one here, core pivot session new. That's when we need to tell MSF about it. Okay, alright, I'm with it now. So what we need to do is we need a facility to send and encode a packet down the wire, as per what we saw down here. Where are you? Server notify, it's this bit here. Yeah. Established. Right, so we need to start doing this. We need to emulate what's going on here. So we create a new packet, which is a request for core get session GUID. I love the unicorn, that's awesome. Okay. Pivot add. So once we've got this core pivot add happening, and it actually happens, our pivot listener, which is an abstract class, of course it is. We need to go to the implementation, which will be NamedPipe pivot listener and all connections. So this is where we go, okay, fire pivot added. We let parent know that a pivot has been created, and we need something that will subscribe to this pivot added notification, which we have done in here. Okay, so when a pivot is added, we store the pivot inside the pivot manager. Okay, so it's at this point now, once we've got the pivot added, we need a mechanism that says, okay, I'm aware of the pivot, and we need to keep track of what was in the pivot event args, a reference to the pivot itself. So here's the question. If we've got a pivot, we need to be able to associate the pivot with an identifier that maps to the listener, if that makes any sense. Is that right? So we store the pivot here, but at this stage, we don't actually have the means to identify the pivot. Or do we? Oh, this is so confusing. Yeah, I think we're going to need to do, when the pivot listener receives a new pivot here, we need to go through the process now of saying, okay, you've got a new pivot. You need to go and do the sort of negotiation across the wires. So let's do that maybe in the pivot itself. Okay, we need to read stuff. We kick off the read thread, which makes perfect sense. But maybe we need to do that after we read the session GUID. So let's go, we'll call it establish session, because that's important. Private void establish session. You're all very quiet this evening. Is it because this is already boring? Or it's because you're as confused as me? So we need to actually have an indication as to whether or not the session has been established. So let's go, we'll have established, if I could type, is false. And so what we want to be able to do when we receive information off the wire is we want to make sure that that has something to do with the message that we've sent out. So when we establish the session, we need to create a new packet. Equals new packet, or is it packet.create? That's going to be a core proto packet. New packet, and we give it the method, which is core get session GUID. Right? So we create the packet, and what do we need to do? We just need to add a request ID, which it should be able to do for us behind the scenes, but we probably need to track it, and this might be the big deal. So we need to track the packet locally. As we can see, you get the packet, you add the request ID, we actually get the request ID out, and we store it inside the current context. Now the context is effectively a mapping to this pivot thing here, right? So what we will need to do is go private GUID, pivot GUID, GUID.empty. We'll just start with GUID.empty. So we create the packet, and we need to we may actually remove this GUID and use the ID that's associated with it here, because that's what we're going to be using anyway, but I'll come back to that. We need a private, that's right, it doesn't need to be the pivot GUID. We need to go private GUID session ID. That's what we need. It's the session ID. Okay, so here we need to go the session ID is not a, leave that there. Private string. This is going to be the identifier for the get session GUID request, right? Get session GUID request ID. We'll leave that as null at the moment. All right, so we need to go this dot get session GUID request ID equals packet dot request ID. So that should be set magically for us, right? But we need to make sure that when the request ID comes back out, that things will behave. This code here is going to change as soon as removal of these things goes away and when we force packet TLV encryption, but we'll get to that another time. So we're going to store the request ID before we send it out because we want to make sure that when it comes back in, it's the packet that we're looking for. Okay, we could actually look at the method as well. I wonder if that's worth doing. We'll just follow the current practice and we'll go from there. Okay, so we then need to basically create the packet and make it, we want to make it serialize itself. That makes sense, yeah? So to raw, now the session GUID at this stage, what do we pass in for the session GUID here? Get GUID packet header. By the looks of it, we don't actually generate a GUID for this packet, do we? Request ID, packet length. Yeah, okay. Right. Rand XOR key, and you put that in the header. Copy the whole packet header over. Don't support encryption at this point, but we do want to XOR, so we would XOR that, and then we just send it in. Okay, so we call to raw, and the session GUID is going to be GUID dot empty, all zeros. Content equals, and that should give us what is effectively a blank packet, right? No argument that corresponds to the required formal parameter of packet encryptor. Okay. So we don't actually have a reference to the packet encryptor, do we? That's because we don't actually want it to use one at this point. Where is the question is the encryptor the thing that does the XORing as well? I was saying encrypt, encrypt, generate random bytes. No, it isn't. AES encryptor and mainstream. Yeah, it only actually does the encryption, so that's fine. So if we don't have a packet encryptor, what we want the packet to do is, so if we go packet encryptor equals null, let's have a quick squiz at what's going on to make sure that we don't do anything stupid. Right, so the TLV data is going to be if the packet encryptor is not null. So packet encryptor oops. So if it's not null, then we want to actually do what we're doing before. Otherwise, we'll just go TLV stream dot to array. Okay, right is 0 XOR key, which gets filled in later. Session GUID is all blank. We don't have a packet encryptor here, so this is important because the flags. This feels like a little bit of a hack. Flags. I wonder if it's worth like having a packet encryptor that can abstract this for us. Hey Bitwise, so maybe instead of doing this, we can do, I wonder if we can do this. Packet encryptor dot blank. Now if we have a public static, can't type today, packet encryptor blank, basically is the equivalent of a null encryptor. You go get and we return what will effectively be the one singleton sort of instance. So we're going to have a private static pack. Where are those K's coming from? Packet encryptor blank encryptor was null. All right, so if the blank encryptor is null, then we want to go create it. And we will always return the blank encryptor. Okay. Come on, go away. There we go. So the blank, and this autocomplete's killing me. Packet encryptor. Now the packet encryptor is basically just a single encryptor that has no values associated with it. So it will encode it with nothing, right? Generate new AES key, blah, blah, blah. We don't need any of that stuff. Now we could do this in a thread safe manner by locking things appropriately, but I'm not going to do that at this stage. We will come back to it. Let's leave that as null. And then let's get rid of this. And get rid of that. And we're going to go packet encryptor equals packet encryptor or packet encryptor dot blank. What do you think? Thread safety. Tim, that's right, who needs it? All I was going to do was put the standard double locking mechanism in here, which would require a lock object as well. Blank lock equals new object. And then we can basically do the same thing again after lock blank lock. Because we have to support back compat with .NET 2 or whatever it is, we have to do this kind of double check, double lock, double check locking things. A lock is basically a fancy keyword over the top of monitors, which are like critical sections almost. They're not like mutexes because locks, they use critical sections and they're not kernel objects. Yeah. If you use a mutex, you end up with a kernel object, which we don't need, which is more expensive and it can be interprocessed and all that sort of stuff, but a critical section isn't one. So it's slightly lighter for this purpose. So it's good to just use those instead. Okay, so that means we can leave this alone. We just default to the blank packet encryptor if we aren't given one. Okay. So, let's go back to where we were here. GUID.empty.toByteArray. That's what we want. So you can't give it a session GUID as a GUID object, which is a bit crap. Maybe what I should do is overload so that we can do it both ways. We can say instead of byte, we can ask for a GUID. And then we can just return this dot to raw session GUID dot to array byte array and pass in the packet encryptor like so. And then this overload should take care of it for us. Isn't this only accessed by the main thread, the one handling the comms? At this stage, no, it's not. It's not doing that at all. Like technically you could create two packet pivots at the same time because they are done on different threads. It's incredibly unlikely, but it's probably just better at being safe. Okay. So now we just need to write stuff. Begin right. We basically need to do the same here. Packet content. So we can go this.server.begin write. This is interesting, right? Because the response that we will get out, we'll see what happens. Wilbertross, greetings. Nice to see you again. So packet content 0 packet content dot length this dot data written. I'll pass in packet content again, but I don't think it's necessary. So when we actually have finished reading whatever that packet happens to be, we are going to have to parse the packet in a typical sense, right? Right, no bugs. I got to get some lunch. Thanks, old son. I didn't see you sneak in, mate. Good to see you. Thanks for jumping on. So what we're going to hopefully see is we're going to send the stage, and then as soon as the stage is sent, we will send the packet that contains this core get session GUID. So I'm going to stick a breakpoint here, and let's go through the process of sorting out the comms. Build succeeded. Oh, hang on a minute. Run. Okay. So if we go session/c, have I got the history? Here we go. This is what I want. It's not. Is it 136 still? 136. Okay, so if we do that, we've created the pivot, so that should be sitting in here ready to go. And now we need to execute this puppy. Okay, we have stage data, so we're going to send that off, and then we're going to jump into session establishment. So we'll create a packet, see what the request ID is. There you go, it auto generates one. Create a packet, which according to this is hex 67 bytes. B96489. Yeah, okay, so it looks like the header is going to be pretty much blank. And we are going to put breakpoints now on both of these and let it go. Okay, so data has been written. And nothing happens. So what I was expecting here is that this read occurs, and when we get the read, that we would start to be able to parse the bytes. But that's clearly not what's happening. So packet, we create the packet here, and we generate a I'm confused. I would have expected to see something come in. NamedPipe write raw. I wonder if we're going to have to generate some Meterpreter payloads that we can use. The packet looked valid. I think the process of creating and serializing the packet was okay. Yeah. I wonder if there's actually a bug in the code that does the. Yeah, I don't know. I think we're going to have to go into like a debug mode here and see what's going on. Because I would have assumed that metserv runs. And if metserv runs and runs okay, then you know it should do its thing as we would have expected. When would read async be triggered? So you mean this call here? This one here on 42? When data comes in off the wire. Actually, this is a key point because once we kick off read async and we should end up here once data has come in. But the assumption here is that we put the packet on the wire and we've sent it off, and the receiver has received that message and is happy to send it back. But I think in order to get to the bottom of this, we are going to have to rethink. Yeah. Did we actually send? We did send this twice, didn't we? Hang on. Yes, I do want to stop debugging. And I want the process to terminate. This is that edge case stuff that's a real pain in the butt. Is pipe still running? Yes, it is. Okay. Excuse me. Add pivot. Run the pipe. Okay, so the data is written. Sync state. There's the bytes that we passed in. Completed successfully. Completed synchronously is false, is completed is true. Okay, so that's fine. And then we do another write. Yep. And then we do the begin read. That's obviously on a separate thread. And this one here says the same thing. We are sending hex 67 bytes with the packet data in it, which starts with a bunch of nulls, which is why we see the XOR key repeat. Okay. And then from here we would expect some information to come out after the read. So read async, fire the pivot added. Now we won't actually fire the pivot added event, I don't think, until we've actually got like a session GUID, which is what happens behind the scenes. But as you can see, we're not getting any information. So read async is triggered, but nothing is being received. That's correct serializing. So that leads me to believe that the Meterpreter stage isn't doing what we would expect it to do. And there's a couple of easy ways to figure that out, but the most, or the easiest, is to rebuild the Meterpreter binaries and drop them on disk on the MSF box, and then push those across the wire instead. So for those people who don't know, I don't know whether I've got Git on here. I think I have. Metasploit payloads. Should do. Great, I don't have Git installed. Typical. Okay, if you would just forgive me one moment, I'm going to be doing something on my host machine. Should allow me to. I'm just going to quickly pop the OPSEC thing on. And the reason I'm doing this is not because I have anything to hide, it's because I am spinning up stuff. Yeah, I can, but just hang on a minute. I have nothing to hide, I promise. Yeah, okay. So let's go back to here. Okay, CBS, GitHub.com, Rapid7, I'm going to put that in C code. I haven't actually used this interface before. It's not framework that I want, is it? It's payloads. Initiating clone. Yeah, go away. Deal with that another time. Now this will probably take a little bit of time because there's quite a bit in there, and then we need to switch branches. Because I believe master has stuff on it that we don't want. Anyway, so for those who aren't familiar with the process of building the Terp, you should be able to build it clean straight out of Visual Studio 2019. That's at least what should be happening. I gotta make sure that I get the right thing. So you see Meterpreter. I'm gonna close that off. Should be done by now. We can actually make with C. Oh, I forgot about that. Can make with CMake. But that stuff hasn't been. I don't know if that's actually been fully merged yet or not. So I want to make sure that I'm on the same branch. So I'm going to open the workspace in 2019. Now, for those people who've used Git inside Visual Studio, you may need to show me the ways. What's the easiest way of changing branches? Is there something in here I can do? Blame, rename. Ah, here we go. Fetch, pull. Team Explorer, is that where it is? Ah, I need to update submodules, don't I? Which isn't really important for the purposes of what I'm doing here, except for RDI. Min cats, I don't really need objective DI injection. Branches. Anyway, remotes. So 6.x I'm wondering if master is okay, because we can't. Let me just quickly check something. A lot of stuff has changed in this recently, which is why I'm kind of like, I can't remember exactly where things are at, but by the looks of it, we should be okay. So if I look in, yeah, okay. Alright, so if I come in here and go CMetasploit payloads, CMeterpreter, I should be able to go make CMake on Studio 2019 and enable debug trace like this. I'm going to close this down in case we tread each other's toes. So the plant layer, this is a bunch of work that I did recently. The make file will actually do the same thing, but you need to be inside a Visual Studio developer command prompt to make this work. Whereas here, if you type make CMake, it'll use CMake as long as it's installed and that you have the DevTools available. But dbg trace with a T should result in debug output sort of being included. And if you go verbose, trace is set to verbose. So there we go. It's going to build the things for me. Now it doesn't take too long. Actually, it's quite fast once the projects and whatnot have been generated. So if you have CMake installed and you have Visual Studio installed, you can just do this, and it's way easier to do it this way and define the debug trace because it doesn't actually doesn't result in you having to modify the code to get this stuff compiled in. So that's pretty much as trivial as it gets, assuming that all the sub-modules and whatnot were updated. This should just build nice and cleanly. Given that we're not seeing any errors just yet, I would assume that it is, because that implies that the reflective DLL injection sub-module had been cloned. So maybe Visual Studio does all that magic nicely behind the scenes for you. I personally prefer the command line. I'm actually surprised that Git is not installed on this machine and is available from the command line, so I'll fix that before the next stream, because I find this not comforting. Okay. There's another thing that's changed. Like on my stream deck, there's a button here that tells me whether or not, like how many people are currently watching the stream, and today it's not working. Go figure. I have no idea why. Okay. So it's done, it looks like it's done the, is it a 32-bit version? Done, yeah, it is brutal, isn't it? Software's terrible. I wonder if it's just some integration thing that's changed and I need to update the Stream Deck config. Haven't heard any Christmas albums so far tonight. Has anyone else heard them? I haven't really been paying that much attention. Man, it's already 50 minutes in. I feel like we've not really achieved much. This is building the old school Mimikatz extension. It's the only thing that has a metric ton of C++ code in it. Don't take away the commands. Lines has needs. Yeah, I agree. No torture yet. Good. Yeah, I don't think I've heard it either. Right, so once this stuff is done, I'm going to need to copy it from the output folder to this PC. I'll probably put it in here. Call it native. What? That's just dumb. Start. Oh, there we go. Righto, so under CMeterpreter. Is that not working because there's no output folder? No. confused by what I'm seeing. Windows, man. It's so weird. Alright, just hang on a sec. I want to make sure that these things actually appear. They look like there you go. So, yeah, that's fun, isn't it? If you don't have the folder on disk, it doesn't do the copy. Which I could probably have just skipped the rebuild and done the copy, but it'll go pretty quickly now. See you, Tim. Thanks again for coming in, dude. Alright, so once these are finished building, I will copy them over. And then over here, we are going to need, let's go to here, and we'll go code, Metasploit framework, data interpreter. Now this is interesting. We've got old DLLs in here. I hate this shell. I'm gonna go back to the one that I had before. Okay. I wonder if that's what was killing us. I didn't realize we had overhanging binaries sitting on disk. Shall we see? See if that while they're building, I'll see if this makes a difference. Get rid of these because we know they're working. And go. Which it's quite easy to delete the DLLs that were sitting there. I have no idea why they're sitting there. They're very, very old. Anyway, lesson learned, always make sure you clean up your mess. I wonder if, like, if I fire up this, I wonder if they will actually spit anything out. Oh, it won't now. So that kicked off, but it's not doing anything. Okay. Kill it all and process stream. The old one's still running. Ooh. What happened here? 0 bytes read. Oh, okay, that makes sense. Because we killed off the connection. That makes perfect sense, doesn't it? Okay, so we'll take a copy of all of these. We'll drop them in native. And then over here, we will copy stream native star.dll to here. Okay, so we should at least see some debug output under the assumption that metserv runs and we end. Oh, look at this. That's interesting, isn't it? Now here we go. Oh, that's not going to work because we have actually staged an invalid version of metserv that doesn't have the debug stuff in it. So we need to end that and this and kick it off again because we need to make sure that when we stage this, this is the bit that I was missing. So oh, okay, yeah, this. I kept missing that before. And I'm not getting the warning now because it's already shown me the warning. So I'm hoping it's picked up the binaries that we've just generated. And we'll see some debug output. Oh, here we go. What's going on here? See you, Wilbertrust. Thanks for coming in, dude. Okay, so I'm a little bit confused by what I'm seeing here. So, where is this stuff coming from? I'm legit confused. So the process that's running here is 8184. So whatever's spitting that debug output out is not doing it. Yeah, I know, dud dude, that's pretty bad, isn't it? What a absolute fail. So maybe this debug output is capturing... Yeah, it's capturing what we're spitting out here. That. Which I'm sure we're seeing here as well. Yep, okay, that makes sense. Alright, so something's clearly up. Our stager that's generating things from the Metasploit side is not coughing up what we want it to cough up. So this is going to get fun. And now we're going to go back into MSF land. And we're going to try and fix it. Okay. Let's ag. I've still got it on here. Core pivot add. Okay. Librex post. I have no idea what the difference between these two things is. Core pivot add. Interpreter loader x64. Transport config. Blah blah blah. Pivot stage. Send request done. So the Meterpreter loader is the thing that we're going to need to wire in clearly, because that's the thing that actually generates the stage. Can't see a reason why. Oh, I might know why this is broken. I might not, but I might. So what I'm going to do is I'm going to edit lib msf core payload Windows x64 Meterpreter loader, and down this is the code, by the way, that generates the Meterpreter stage. So you'll see here that it reads metserv from disk, and it does a bunch of magic stuff by on the fly compiling a blob of assembly code that knows how to kind of hot load itself as shellcode by invoking the reflective loader. So what we need to do is make sure that this is actually functioning correctly, and the best way to do this is right down here, where we actually, after staging the Meterpreter, it returns the DLL as it's currently packed. We just prepend a breakpoint. Okay. So by doing that, when we create a new Meterpreter stage to send down the wire, it should include a breakpoint. So after spinning this up, we can add the pivot, and then at this end we've got to open up a 64-bit assembly debugger, and we need to spin up this puppy. I realize that the font on screen right now is going to be agonizingly small, and I apologize for that. But it is what it is. Now check this out. We have clearly not hit a breakpoint at all, which kind of to me implies that we haven't read everything out. So we may need to generate a new stager that can do this for us. Okay? So I'm going to close that off. I'm going to close that off as well. And we're going to go back to Metasploit. And what are we going to do? We need to open up the stager, which is going to be modules. No. Let's go back up. We want to open modules, payloads, not singles, stages, Windows x64, reverse named pipe. Okay. Guilty is charged. So there's this payload Windows reverse named pipe, which we need to edit as well. That's basic. This is just a placeholder for the code that does the name pipe stuff. So that means we need to open up lib MSF4 payload Windows x64 reverse name pipe. Now, here's the code that we use to do all the things. As you can see, it's a little bit convoluted. But what we need to do is we know that we're able to open the named pipe, okay? So let's have a quick look. This label is required, so to reconnect attempts include the UID stuff required. Don't need that. Reliability, don't need that. Allocate a read-write X buffer for the second stage. So slight stack adjustment, page execute read-write. Here we're calling virtual alloc. So by this stage we have connected back and we've read something in. Because to start with, we read 4 bytes in and that tells us how much stuff. So see this? Receive the size of the incoming second stage. Int 3. So that's what we're going to do. We're going to set a breakpoint here and regenerate. Hello, QMCPZZS. I always struggle with that. Thanks for joining again. It's nice to see you. And so let's go. MSF Venom. Actually, do we have a history for this? Bugger. MSF Venom. Payload Windows x64 interpreter reverse named pipe. We need to go pipe name equals. Yeah, I know. Got to remember. Hindu Kush, how's it going? Pipe name is MSFX64. Yeah, is that what it was? MSFX64. Pipe host. I think it's effectively ignored. That's a good question. But clearly I blow away my history on this. Yeah, tab autocomplete would be lovely, hey, but it's an absolute nightmare to implement here. I should actually just generate this every single time. Pipe host will be 192.168.146.130. Hang on a sec. Yeah, 136. Okay, sorry, my bad. 136. What else? I think that's all we need to specify. Format exe output to stream interpreter.net. I'll shove it in the native folder as well, and we'll call that pipe64. Put CC in there so that we know there's a breakpoint. And let's Let's see if it generates appropriately. Oop. Ah, okay, that's interesting. It looks like I haven't mounted this as read-write. Maybe I can drop it in stream. Stream. Yep, I can. Okay, let me just grab a copy of that. Come over? Didn't do it. There it is. So I was just dragging that across VMs. Okay, so let's try this again. And open that up. Just leave it hanging there for a minute. Spin this up again. Spin this up again. Alright, moment of truth. Do we hit a breakpoint? Yes, we do. Okay, so at this point, this next call here, you can see we're actually reading 4 bytes into a buffer located at, what is it? Let me find the code again. We're reading 4 bytes. Buffer for number of bytes read. Ah, we're reading it onto the stack. That's a no-brainer, so we should see it appear somewhere in here. Let's take this address and write it there. Now, where did it get written to? Actually see that get written, and pop RSI. That looks like a lot. Okay. Pop off the second stage length into RSI. So RSI, according to what we're seeing here, it thinks that the second stage length is this many bytes. Clearly that's a problem. That initial generation time does only check. Yeah, okay, so it generates the payload and then tries to write the payload to disk, and it fails when it tries to write the payload to disk, which is after the payload has been generated. So it doesn't try and create the file, then generate the payload and then write. It does all of the generation and then tries to write, which is why, yeah, which is why it took that long. Okay, so what I need to determine at this point is whether or not the problem exists in the stager or in the stage, because I haven't used this code, particularly not in 64-bit, for quite some time. But yeah, clearly this is the spot that it should have been written to. So R9 is where Alright, I'm gonna redo this. Yeah, keep going. this died. That would make sense. So welcome to my life, by the way. Behind the scenes when I'm debugging this kind of stuff, this is exactly what it looks like. Okay, here we go. So when we call this, R9 should point to the location where we want this stuff to be stored, which is just there. So we should see whatever it is that we're reading off the file handle, we should be reading 4 bytes into that location, right? Now this is interesting because it's clearly changed the value there. And that's where we told it to write to based on the code, yeah? So push 0 because that's where we're going to be putting things. Store the current address on the stack. Buffer for LP, oh hang on a second, number of bytes read was 4. LP buffer is in RSI, which will have changed now, so I misread that. Relix, shouldn't it check first if the user... Well, it's an order of operations issue. Like, clearly it'll just go, oh, I can't write there, and you do know about it. The question is, do you look at all the locations where users want to write stuff up front or not? So I would argue no. It's not really the responsibility of the app to upfront make sure that what you're telling it's correct. It's going to try and do it in the order that makes sense, and if it can't do it, it's going to tell you the error, which is exactly what it's doing. Right, so is that what RSI was before? Because that's a very, very big number. So that makes me think that there's something going on with what we are passing in. So what I'd like to do is quickly go back to our stage data. Aha, I think I know what's going on. In fact, I'm almost certain I know what's going on. Before I tell you, can you tell me by looking at the bytes that we're seeing? You ready? Pop RSI. So RSI contains that. What does that look like? Can anyone tell me what that looks like? Those 4 bytes. I'm so glad that this is exactly what's wrong because I was concerned that something else was going wrong. But you should be able to see that. What are those characters, Barney? Start from the right. Numbers and letters, exactly. PE header, thank you. PE header. So 4D, 5A, MZ. It's a PE header. Check out this first byte. What is this first byte? The CC. CC in hex is what? Come on, serializing. I know you know this. Breakpoint. Where did that breakpoint come from? Let me give you a clue. Here. We put it in. So that's the breakpoint that we put in. So that tells me this. Let me show you. I'm glad we did. This is a fun little exercise, and hopefully you've all learned something from this because I know I needed a refresher. But check this out, right? If we have the stage data, the first thing that we write is the size. It's the size. And then we write the actual stage. So, if we have a look at the code that I wrote, and by I mean you, see how we actually call begin write. and we just pass the stage in. We don't tell it how big it is. Right? Yeah. All right, so I'm not going to store the stage data as it currently stands anymore. We're going to actually generate something else. I know, I feel like a goose. We have two choices. We can call begin write. We can call begin write and just send 4 bytes and then call begin write again straight afterwards and send the stage. Well, let's see what happens when that happens. So stop. Now what we need to do is be able to convert this to bytes. And we don't want to do any endian switching in this scenario. We just want to write the bytes as they currently sit. So in order to do that, we need to, what's the easiest way of converting an integer to bytes? Just by casting it. Anyone? Can anyone tell me? I might actually do it the easy way. Can we write something? We can only write that. If we go new stream writer, what can we write? Char. Alright, so here's what we're going to do. We're going to go using var memstream equals new memory stream, and we're going to be smart and say we want stage data.length plus 4 bytes. And then we're going to go using var writer equals new stream writer memstream, and then in here we're going to do something smart. Like so. We are going to writer.write, and we're going to pass in an integer. Well, the thing is the get Tyranido. Tyranido's here. Bitconverter.getBytes. Does that actually convert directly, or does it do any byte swapping? It probably just converts directly, doesn't it? You are right. Why am I questioning you? I didn't realize you were here, mate. How you doing? Length is an int. Doing okay. So that should write the int. And then writer.write. And then we can pass in stage data. And that should just write the bytes. And then we can go stream.to array and let it do its thing. Converts to the machine's endian. Has it is little endian property which tells you what. Okay, yeah, right. It does do that. Okay, cool. Thank you. Build. I kind of like the idea of creating a new array and just writing it all in one rather than doing 2. The protocol is pretty much all binary based in this particular context. We've got the data that's coming off the wire. We need to just send the length just as a straight up int before passing it off. Binary writer, not oh, do I? I thought stream writer would take an int. Oh, hang on. Right. So if we can pass in an int, does that not do it? It does, but it's a text stream. Okay. Thank you for the heads up there, mate. Oh, this is a great song. Thank you. You've just saved me some heartache. Yeah, cool. That makes way more sense. And this is why you are the smart guy. Okay, let's do that again. Now this should hopefully make a lot more sense. Let's restart that. Okay, let's quickly look at what RSI is here. Is that what it is? FED0. That looks a bit more sane, doesn't it? And there's the start of MetServ, and boom! Check it out. Who'd have thought that doing things as per the protocol would like work and stuff? Okay, so at this point we've read a new block of bytes, and we basically need to do a couple of things. We need to do like a header parsing kind of thing. And then we need to look at the content of the header, and we need to say, let's pull that apart. Let's do the opposite of encryption. So we'll let the packet thing try and pull itself apart. But what we want to be able to do is just keep reading until we've got all of the things that we need to be able to determine whether the packet itself is intended for consumption by us or intended for consumption by Metasploit. Thank you, Tyrannido, for all of that, and all you people for your insights. That was helpful. I am going to avoid using the break-pointed versions of things now, because I don't think that the problem now lies with the native stuff. So let's go back to here. Sorry, this one. So we're just going to return the DLL now. I can get rid of that as well. Now I don't need to regenerate the payload, but I do need to restart MSF, because that I'm just going to use the pipe.exe that was on the desktop to do what it was doing. And given that all the breakpoint code was hard-coded by Metasploit, I don't need to regenerate payloads from the payloads source either. We just need to kick things off again. And on this machine, we can close this down now. We'll keep this open. Look at that, it's actually doing things. So if I run this, what happens? Nothing, because I haven't set the pivot up yet. Did the process die? Yep. Okay. There you go, check it out. It's actually sitting there waiting on the pipe. Alright, so we can see that we have read hex 83 bytes, and in our read buffer we should see some info. And there you go, it actually looks like a packet, right? So what we're going to do now is we need to say, you know, have we actually read some bytes? Can we pull that packet apart? So if we go var packet equals new packet, and so we can give it a binary reader, which can effectively be wrapped up in the stream, right? So if we went var, let's do what we did before over here. Sorry, I'm bouncing around all over the shop at the moment. Let's do this again. Is this what we want to do? Yeah, it probably is. We can get rid of this. instead of reader, sorry, writer, we want a binary reader. It's funny because I was using binary readers before, binary writers before. I'm clearly dumb. Clearly dumb. Equals new packet reader. Now we'll go and sort the overload problem out here as well. Binary reader packet encryptor. So let's take a dupe of this. There we go, equals null. No, we don't need to do that. Let's do that there. And before we do anything, we can go packet encryptor equals packet encryptor or packet encryptor dot blank. So we're going to do the same on the other side. Okay. Now the interesting thing will be, will this actually work with a blank decryptor in other contexts as well? Yes, that's a good idea. That's a good idea. Actually, no, I want to, yes, the bytes read, which would be this.read buffer. Thank you, Tyrannido. I do need to do that so that we can actually read the data that came off the wire. Thank you, sir. You are indeed correct. Okay, so what we'll come back to this later on because we want to make sure that we've read all of the data that comes off the wire. So at this point, we want to check if packet, actually we should check if this dot established. So if we haven't established ourselves yet, and packet dot request ID was this dot get session request ID, then we know we've got a response to our packet that we sent outwards, as per what the native implementation does, right? Does that make sense? So that's happening just up here in toggle, past the security related stuff, name pipe, right raw. Here we go. This stuff here. Okay. Request ID found, matches expected value, pull out the session GUI. And we can get that from the header. There should be a session GUID associated with this. But clearly we're not even parsing it yet. Packet body parse data. So this. Yep. Parse data, packet type. Right, so question is, where do we skip the session ID? To yeah, so we're going to need to put where is it? Method. You presumably, yep, we've already addressed that, haven't we? Sorry, I'm just I'm wondering how best to extract the session GUID from the content at this point. What would be really nice is if we could actually just wrap up the named pipe reading process as a stream. That would actually support what we're doing here much nicer. Does anyone know if that's even possible? James, maybe you would know. So at the moment we're doing this begin read and begin write. What I'd love to be able to say is like, give me a stream to read from. Which I'm guessing isn't going to be that simple. there's got to be a way of wrapping this up as a stream thing. Is it already one? Oh, it is one. NamedPipeServerStream. Yeah. I think I might have to change this so that this functions in a similar way to how TCP sockets function. And we can just basically say, go and read a packet off the wire. So read async would effectively be doing this. We need to do it on a thread though. Yeah, so if we did this instead, forgive me for going off on a little tangent here, but I think this will make the code considerably nicer to read. Yep, this is definitely worth doing. We're going to have a reader thread, and we're not going to have a writer thread. So we'll go private thread. Please give me the threading things. So we'll go reader thread equals new thread. So we should do that in the constructor, shouldn't we? Like, just so that we're consistent. Okay, so this dot reader thread equals new thread. We don't need a parameterized thread start, we just need a thread start. This dot read async. So read async should already have the right signature. And then here we just need to kick off the thread. Once we've called established session, we can go to this dot reader thread dot start. We'll handle the other things later. So here's what I'm thinking we should be doing instead. Is we don't need to call begin read. We can just go and do exactly what the transport related stuff does on the TCP side, and just tries to read the next packet off the transport. So if we look at the way the TCP transport, let's see how we've got this receive packet encryptor. You can see it's doing it and saying try and read some stuff off the wire, return new packet, this.tcp reader packet encryptor. So all we need is to go var packet equals new packet and give it this.server, because that is actually a stream. TCP reader is a binary reader. Okay, so we can just go using var reader equals new binary reader and give it, hopefully, this.server. Yeah. And then we can just tell the packet to read directly off the reader. Yeah? And we can do the same thing on the other side when it comes to writing information. So let's get rid of this. We'll steal that bit of code, but we'll get rid of all this. And we don't need a data written. We just need the ability to write. Question is, do we want that to be asynchronous? I'm assuming we don't at this stage. So Let's just do this. We'll go private void. I guess we probably do want this to be asynchronous, don't we? What do you think? Hey, Ricky33, your name's familiar. Yeah, so I think we might actually do this. Yeah, let's do this. We're going to say write. We're going to have a write raw function which takes the bytes, the data to write. And we're just going to do a fire and forget thread, right? We're just going to go. Can we actually use actions here? We probably can. Hey, new thread. Parameterized thread start. New parameterized thread start. Can we give it an action here? I assume we can. Yeah, we can. This is pretty filthy, but does the job. In fact, we don't even need to make it parameterized because we can still reference it from within the closure. So let's do that. Using var writer equals new binary writer. This.server. That should work. Yep. So once we've got the writer, we can basically, what can we do here? Writer.write. And that should be okay, right? So write raw will do that. In fact, we don't even need a write raw. We can just call it write and have overloads. So void write. If we give it a packet instead, we can serialize that packet. Packet.toRaw. We'll have to give it what our current session GUID is, which is GUID.empty. Okay, so toRaw would be this dot session ID, and when we get our session ID out, we'll overwrite it. So from then on, we'll actually have the right session ID included. Okay, so then we can just go write the raw version of ourselves. Yeah. So from here, we can just say write packet. Pass the packet down to here, which will then write it asynchronously. And then here we're reading asynchronously, and at this stage, when the packet is read off the wire by using the binary reader, we should have various other things in play that we can just read straight off. But what we clearly need to do is extract the session ID. Now, in this case, if this hasn't been established yet and we match, then we want to actually get the session ID out of the packet, not out of the packet header. So packet.tlvs dot try and get TLV value as raw. Now we want, what is the TLV type again? It's here, isn't it? That's the request ID, session GUID. Okay. Let's see what this looks like. See if we even get here. Is everyone clear on what we're doing? How are we doing for time? Jeez, it's 20 to 10. Eh. Now what we can do here is, instead of all of that nonsense, we can go write memstream dot to array. Then we can get rid of this read buffer, because we're not using that, which I prefer, to be honest. Reader third, read async. All right, that's looking better. Let's see what happens when we get here. Kick off pivot. Cross fingers. All right, here we go. Oof. Cannot access closed pipe. Something broke, didn't it? I wonder why that is. Okay, so what I'm going to do to begin with, I'm going to just quickly comment this out. And we'll do this synchronously and see if it actually works. Question is, if we see this binary writer, maybe the problem is that the binary writer, when we close it, actually closes the underlying stream. So maybe we shouldn't be doing this. Maybe what we should be doing here is having a private binary writer, and a binary reader. It's probably closing the underlying streams, yeah? And then here, before we kick things off, we can go this dot writer equals new binary writer, this dot server, and then we can do the same with the reader, like so. And then we don't need to do the using. We can just use this dot reader. And then down here we don't need a using. We can just use this dot writer. We'll keep that write synchronous for now. Let's go again. Oh, hate it when that happens. Okay, spin up pipe again. Okay, so I would assume that at this stage where it's actually reading the packet off the wire, we're going to have to step in. Didn't crash that time at least, right? So let's just go back here. And we'll see what happens. Right. So we have a blank encryptor, which is what we would expect. Packet body, read, header size. So it's going to try and read. Isn't that interesting? It's going to try and read a certain number of bytes, and it's not happy about it. Wonder why. I would have thought that you can do maybe you can't. Maybe you literally can't. What do you guys reckon? My feeling is that maybe doing the binary reader option doesn't work in the way that everything else does, even though that the network, the NamedPipeServerStream is a stream. Maybe calling read bytes at this point doesn't work. Because clearly we're able to, like, header size here is 32 bytes. We know that the first blob of data that came down the wire had way more than 32 bytes. So we should be able to read that many bytes out of the stream when it comes in. Yeah, that's a bit strange. Excuse me. Right, so reader.read bytes. So the size is 32. It's a CLR immediate window. So what if we did this? Reader.read bytes. So if we just did read byte, what happens? Isn't that interesting? BinaryReader NamedPipeServerStream. Let's see if there's some known issues here. There we go, C# server.net NamedPipe. Reader and writer. BinaryReader. So according to this is not doing anything different to what we do. Attempting to share a NamedPipeServerStream is between two threads. A reader and a writer. The program works on an attempt to create two instances of process. Okay. You cannot create multiple instances of NamedPipeServerStream with the same pipe name. Okay, so that is in no way helpful. What I'm seeing here is no different to what I'm doing, except for the fact that it's not async. But that shouldn't matter, right? That shouldn't matter at all. I've lost everyone. .NET stream. Reads a sequence of bytes from the current stream, writes them to a byte array, and advances the position within the stream by the number of bytes read. That's not what I'm looking for. Let's go to NamedPipeServerStream. For some reason it defaults to .NET Core. We want Framework 3.5. And then methods. Maybe I'm doing something really dumb. Yeah, I agree. We've got a NamedPipeServerStream, which is no different to a NamedPipe client stream at this point, right? Get a connection. We wrap the pipe server in a stream. They're doing exactly what we're doing. This is not using streams by the looks. Is message complete? So that's using the same thing that we were doing, but it's synchronous reading rather than asynchronous. That's just a dupe of Stack Overflow. Yeah, I'm confused. Genuinely confused, because what I can tell, I'm not doing anything that I shouldn't be doing here. We're doing exactly the same. Exactly the same as what the others are doing. We're wrapping the... Let me just try something for a minute. So we don't do that. Let's do this. Data, 0, data, count, length. Let's see if wrapping it up in just a reader stream to see whether or not that actually makes things behave. I'm wondering if having both a read and write stream for some reason causes problems for it. I wouldn't think that it would, but stranger things have happened, right? Okay. Step in, try and read bytes, and it hangs. Yeah, I don't know why. What I was hoping for is that this abstraction, this stream abstraction, would just allow the parsing of the packets to just happen magically, because clearly we have the means to do it. We know how to handle stuff as coming off a binary reader, and we've wrapped our stream in a binary reader, so you would kind of hope that it would just work. But clearly not. So here's the thing, it's 5 to 10, I have to finish at 10 tonight because I have more work that I have to do before I go to bed. So I am going to stop it now. But while I'm away for the next week before we do the next stream, I'm going to go and do some playing with this so that next time we're on stream, we can hopefully finalize it. Yeah, more work. I know, right? It is 10 p.m. and I need to do more work. Yeah, I'm a bit confused. I thought that wrapping something up in a binary reader, given that the reader works off a stream, and that this thing is apparently a stream, that it would just work. But yeah, I have no idea. So on that rather depressing and unenlightening note, I'm going to call it a halt for the evening. Felt like we didn't really achieve much, but you know, can't have wins all the time, hey. But on the plus side, I think we all learned something there. I mean, you can see the debugging and build process for the native Meterp to see what was going on, which I think was useful. But yeah, I don't know what's going on. So I'm going to go and have to find out. Name pipes are dreadful. I agree, Rasta. They are indeed dreadful. I'm sure there's probably just something that I need to... There might be like a setting on the name pipe that I need to set to say that I'm happy for this to be working under the context of a stream or something like that. That's usually what it is. Go and turn this property to true and everything will just work. So maybe that's what I need to look into. But in the meantime, stay safe. Keep washing your hands. Thanks as always to all those people who have subbed and supported me and the Patreon people out there. Much love. It's always great having you folks on stream. Even when it's boring, so I'm sorry about that. But hopefully next time we'll get some more wins and we'll finalize things. So yeah, peace. Thanks again. All the best and be good to each other.